Good morning everyone, this is my video in completion to my subject Math A. General instruction. Problem instructions. So here is the given number 1. Y is equal to negative x squared plus 1 and y is equal to 0. So now let's find the volume of the solid that results when the region enclosed by the curves is revolved about the x-axis. Let us use the formula pi integral from 1 negative 1 of negative x squared plus 1 squared dx. So let us simplify it to integral from 1 to negative 1 of pi 1 minus x squared squared. In computed antiderivatives, here is the steps in manual integration. So the problem is pi 1 minus x squared squared dx. And so we will expand it to integral pi x to the fourth minus 2 pi x squared plus pi dx. Let us apply linearity so it becomes pi integral of x to the fourth dx minus 2 pi multiplied by integral x squared dx plus pi integral 1 dx. Now let us solve first the integral x to the fourth dx. Let us apply the power rule. Integral x raised to n dx is equal to x raised to n plus 1 over n plus 1 with n is equal to 4. So it becomes x to the fifth over 5. Now let us solve for integral x squared dx again by applying the power rule with n equal to 2. So it becomes x cubed over 3. And thus integral 1 dx and apply constant rules, so the answer is x. Let us now plug in and solve integrals. Pi integral of x to the fourth dx minus 2 pi times integral x squared dx plus pi integral 1 dx is equal to pi x to the fifth over 5 minus 2 pi x cubed over 3 plus pi x. The problem has been solved. Integral pi 1 minus x squared dx is equal to pi x to the fifth over 5 minus 2 pi x cubed over 3 plus pi x plus c. Or in simplest form, it is pi x times 3x to the fourth minus 10x squared plus 15 over 15 plus c. In antiderivative computed by maxima, integral f of x dx is equal to f of x. So the f of x is equal to pi times x to the fifth over 5 minus 2x cubed over 3 plus x plus c. Applying the definite integral from 1 to negative 1 f of x dx is equal to integral from 1 to negative 1 of pi x times 3x to the fourth minus 10x squared plus 15 over 15 is equal to 16 pi over 15, or to simplify, it is equal to t.351. Here is the given number 2. Y is equal to 2x plus 2 and y is equal to x squared plus 2. Now let us find the volume of the solids that results when the region enclosed by the curves is revolved about the x-axis. Upon finding the volume of the solids, let's use pi integral 2 to 0 of 2x plus 2 squared minus x squared plus 2 squared dx. And now we will simplify it first to pi 2x plus 2 squared minus x squared plus 2 squared. Here are the steps in manual integration. First, let's identify the problem. So here it is. Integral pi of 2x plus 2 squared minus x squared plus 2 squared dx. Now let's apply linearity. 4 pi multiplied to integral x plus 1 squared dx minus integral x squared plus 2 squared dx. And now let's solve first the integral x plus 1 squared dx. Let's do substitution. U equal to x plus 1 for du over dx equal to 1 to dx equal to du. And it is integral u squared du. Now let us apply power rule. Integral u and du equal to u raised to n plus 1 over n plus 1 with n equal to 2. So it is equal to u cubed over 3. Now on the substitution, u equal to x plus 1. Here it is x plus 1 cubed over 3. Next, let us solve for integral x squared plus 2 squared. Let's expand it to integral x to the 4th plus 4x squared plus 4 dx. Then apply linearity. It becomes integral x to the 4th dx plus 4 integral x squared dx plus 4 integral 1 dx. Next, let us solve integral x to the 4th dx. Apply power rule with n equal to 4. It becomes x to the 5th over 5. Then solve for integral x squared dx. Just use the previous result, which is x cubed over 3. Last, let us solve integral 1 dx and apply constant rule so it is equal to x. Now let us plug in solved integrals. Integral x to the 4th dx plus 4 integral x squared dx plus 4 integral 1 dx is equal to x to the 5th over 5 plus 4x cubed over 3 plus 4x. Then plug in another solved integrals. 4 pi multiplied to integral x plus 1 squared dx minus pi integral x squared plus 2 squared dx, which equal to 4 pi x plus 1 cube over 3 minus pi x to the 5th over 5 minus 4 pi x cube over 3 minus 4 pi x. Then the problem has been solved. Integral pi 2x plus 2 squared minus x squared plus 2 squared dx is equal to 4 pi x plus 1 cube over 3 minus pi x to the 5th over 5 minus 4 pi x cube over 3 minus 4 pi x plus c. Let us simplify it to negative pi x squared x cubed minus 20 over 5 plus c. In antiderivative computed by maxima, integral f of x dx is equal to f of x, which f of x is equal to pi 4x squared minus x to the 5th over 5 plus c. Last, apply the definite integrals. Integral 2 to 0 f of x dx is equal to 48 pi over 5, or to simplify, it is equal to 30.159. Here's the given number 3. Y is equal to square root of x plus 1 and y is equal to x squared plus 1. And the given axis is y is equal to negative 1. Now let's find the volume of the solid that results when the region enclosed by the curve is revolved about the given axis. Upon finding the volume of the solid, let us use pi integral 1 to 0 of square root of x plus 2 squared minus x squared plus 2 squared dx. Then we will simplify it first to pi square root of x plus 2 squared minus x squared plus 2 squared. Here is the steps in manual integration. First, let's identify the problem. So the problem is integral pi square root of x plus 2 squared minus x squared plus 2 squared dx. Then apply linearity. So it becomes pi integral of square root of x plus 2 squared dx minus pi integral x squared plus 2 squared dx. Now let us solve one by one. First, we will solve integral square root of x plus 2 squared dx. Then substitute u equal to square root of x of du over dx is equal to 1 over 2 square root of x. So dx is equal to 2 square root of x du. It is equal to 2 integral u minus 2 u squared du. Now solve for integral u plus 2 squared du. Substitute v equal to u plus 2 for dv over du equal to 1. So du is equal to dv. So integral u plus 2 squared du is equal to integral v minus 2 v squared dv. So let's expand it so it becomes integral v cubed minus 2v squared dv. Then apply linearity so it becomes integral v cubed dv minus 2 integral v squared dv. Next, we will solve for integral v cubed dv. Apply power rule. Integral v raised to n dv is equal to v raised to n plus 1 over n plus 1 with n equal to 3. So it is v raised to 4 over 4. Let's proceed. Solve for integral v squared dv. Again, apply power rule with n equal to 2. So it is v cubed over 3. Now let us plug in integral v cubed dv minus 2 integral v squared dv is equal to v to the 4th over 4 minus 2v cubed over 3. On the substitution, v equal to u plus 2, so it is equal to u plus 2 to the 4th over 4 minus 2u plus 2 cubed over 3. 2 integral u of u plus 2 squared du is equal to u plus 2 to the 4th over 2 minus 4u plus 2 cubed over 3. Again, on the substitution, square root of x plus 2 to the 4th over 2 minus 4 square root of x plus 2 cubed over 3. Next, let us solve integral x squared plus 2 squared dx. Let's expand it to integral x to the 4th plus 4x squared plus 4 dx. Then apply linearity so it is equal to integral x to the 4th dx plus 4 integral x squared dx plus 4 integral 1 dx. Let us solve first the integral x to the 4th dx, then apply power rule with n equal to 4. It is equal to x to the 5th over 5. Next, let us solve for x squared dx. Just use the previous result, which is the x cubed over 3. And let's solve for integral 1 dx and apply constant rule, then it is equal to x. Now, let us plug in integral x to the fourth dx plus 4 integral x squared dx plus 4 integral 1 dx is equal to x to the fifth over 5 plus 4x cubed over 3 plus 4x. So, the problem has been solved. Pi integral square root of x plus 2 squared dx minus pi integral x squared plus 2 squared dx is equal to negative pi x to the fifth over 5 minus 4 pi x cubed over 3 minus 4 pi x plus pi times square root of x plus 2 to the fourth over 2 minus 4 pi times square root of x plus 2 cube over 3 plus c. To simplify, it is equal to negative pi x squared times 6x cubed plus 40x minus 15 minus 80 to the power of 3 halves over 30 plus c. In antiderivative computed by maxima, integral f of x dx is equal to f of x, which f of x is equal to pi times negative x to the fifth over 5 minus 4x cubed over 3 plus x squared minus 2 plus 8x to the power of 3 halves over 3 plus c. And let's simplify it to negative pi times 6x to the fifth plus 40x cubed minus 15x squared minus 80x to the power of 3 halves all over 30 plus c. Last step, apply the definite integrals. So, integral from 1 to 0 of f of x dx is equal to 49 pi over 30, or to simplify, it is equal to 5.131.